we're facing a man-made disaster of global scale, our greatest threat in thousands of years, climate change. If we don't take action, the collapse of our civilizations and the extinction of much of the natural world is on the horizon.
Over the past few decades, the climatic shift has attracted attention on a global scale. Additionally, these climatic fluctuations have a variety of effects on earthly life. The ecosystem and ecology are being impacted in different ways. Numerous plants and animal species have fallen extinct as a result of these changes.
A research study on evaluation of climate change impacts on the global distribution of the Calliphorid Fly Chrysomya albiceps using GIS was published last 20th of July in the year 2022 with the following authors. We all know that climate change is expected to influence the geographic distribution of many taxa, including insects. Chrysomya albiceps is one of the most pervasive Calliphorid fly with apparent ecological, forensic, and medical importance. However, the global habitat suitability is varied due to climate change. Models that forecast species spatial distribution are increasingly being used in wildlife management, highlighting the need for trustworthy techniques to assess their accuracy. This study aims to predict the global current and future distribution of the C. albiceps using the species distribution modeling approach. In addition, it aims to answer the important questions of how climate change will reshape the C. albiceps global range through the next 50 years using different climatological scenarios. Now, the Geographical Information System, or the GIS, and its modeling tools help scientists in mapping the distribution of insect pests, develop models assessing the suitability of certain environmental conditions for sustaining specific insect species under current or future conditions, and presage where species might find suitable conditions and become established with economically important consequences. Predictive models can be useful, complements including those developed to predict a pest's spatial and temporal expansion after its first introduction into suitable habitats, or estimate increasing economic losses to the livestock sector in addition to evaluating the status of important species such as the C. albiceps. And for the methods or the materials of this study, so the researchers used the maximum entropy implemented in Maxent to predict the current and future potential global geographic distribution of the C. albiceps, and algorithms of the DIVA GIS to confirm the predicted current model. The Maxent model was calibrated using 2,177 occurrence records based on the jackknife test. 4 bioclimatic variables along with altitude were used to develop the final models. For future models, 2 representative concentrations pathway, or the RCP, 2.6 and 8.5 for 2050 and 2070 were used. The area curve and true scale statistics, or the TSS, were used to evaluate the resulted models with values equals to 0.92 and 0.7 respectively. Global C. albiceps occurrence records were collected from different digital databases, including the Global Biological Information Facility, and its occurrence data were about 3,500 georeference points. The data were subjected to three major filtration steps, which included removing duplicated data, cleaning records without latitudes and longitudes, and finally, spatial verification of points by distances. The remaining records with 2,177 points were converted to comma delimited, or the CSV format, or file type, and utilized to predict the current and future global distribution of the C. albiceps, as you can see in Figure 1. The results and discussions has 2 models, the Maxent and DIVA. The global potential spread of C. albiceps under current climatic conditions is presented in Figure 3. So both models resulted from Maxent and DIVA showed compatible habitat suitability for the species mentioned, spreading and agreed with the actual distribution of C. albiceps. This insect is considered to be a cosmopolitan species inhabiting all continents except Antarctica. In Africa, Maxent and DIVA models showed very high and excellent habitat stability of C. albiceps in the countries of North Africa, ranging from Egypt in the east to Morocco and West Saharan in the west. Besides, the Horn of Africa and Southern Africa showed medium to very high suitability, while subtropical Africa illustrated no suitability in both models, as you can see in figure 2AB. In Asia, China, North and South Korea, and southern parts of Japan exhibit very high and excellent suitability for the fly's existence. In Europe, the resulted models revealed very high and excellent suitability throughout major European lands, including Italy, France, Spain, Portugal, and Netherlands. It includes also the territory of Netherlands, England, Greece, and Turkey, while the northern territories of Europe showed low suitability. In North America, the resulted current models indicated low suitability in sea albicep distributions over its land, except the western coast of Canada and parts of the United States. The eastern southern coast of the Mexican Gulf showed very high excellent suitability. In South America, Brazil, Uruguay, and Chile illustrated very high suitability in the resulted models. Finally, northern Australia appeared to have a low suitability, but southern parts of Australia, including New South Wales, Sydney, and Melbourne in Victoria, showed very high suitability. And meanwhile, New Zealand showed also very high suitability, as you can see in the figure 3AB. Future potential distribution of the sea albiceps, the Maxent models for the potential distribution of this species under future climatic change scenarios, RCP 2.6 and 8.5 for the years 2050 and 2070, are illustrated on figure 4. In Africa, our predictive models assured very high suitability in North Africa, no suitability in sub-Saharan Africa, and low suitability in subtropical Africa. However, the highest RCP, 8.5 in 2070, was found in subtropical Africa, ranging from Somalia in the east and Senegal and Sierra Leone in the west, which showed very high suitability. In Asia, the future Maxent models predicted notable changes in the suitability of the said species rather than the current prediction, where countries such as China, North and South Korea, and southern parts of Japan exhibit medium to low suitability, as you can see in figure 4. In the same figure, the western parts showed medium to high suitability in the future predictions. In North America, the southern coast of the United States revealed medium to low suitability, while South America, northern parts including Colombia, Venezuela, Ecuador, and the main parts of Brazil and Bolivia illustrated high to very high suitability. Finally, southern parts of Australia exhibited low to medium suitability, and the future models predicted no changes in New Zealand. Throughout the long history of our planet, ladies and gentlemen, the cycles of climate can be considered a natural issue, but anthropogenic activities disrupt such a harmonic cycle and drive the Earth to global warming. The changes that will affect life on Earth in a wide range to form from species range shift to complete extinction. Files of the order Diptera are not far from such alterations. Many species of medical and veterinary important flies will alter the way by which they are distributed through space and time, including that of the genus Chrysomya. Two modeling techniques, the Maxent and Clean model incorporated in Diva GIS, were used to predict the current suitable habitat of the sea albiceps depending on the climatological parameters. Both are simple, effective, and easy to use, but Maxent is better and widely used. This is because of its ability to deal with presence-only data with small sample size and its outstanding predictive performance due to the artificial intelligence of maximum entropy implemented in it. The acquired maps of the two modeling methods look almost identical. The represented suitable habitat appears compatible with the current distribution of this insect throughout the world today. The generated calibration maps that measure alteration in species distribution shows how this fly will lose many parts of this distribution range throughout the world, especially in regions with the Mediterranean climate, or the Mediterranean coast of Europe and Africa, Florida of the USA, and the coast of Australia, as you can see in the previous figure, the figure 5. The direct effect of such changes cannot be predicted easily, and more studies are needed to appraise the values of this fly, especially on the local scale. And in North Africa and parts of Southern Europe, the sea albiceps is predicted to completely disappear. This present work forms a warning on how climate change will alter the global geographic distribution of sea albiceps. From the resultant predicted maps, sea albiceps, a huge distribution range, and consequently negative influences will appear, and pollination, forensic, and even ecological role levels. All efforts should be taken to decrease greenhouse gas emissions on all levels, from the decision makers to the normal layman, to prevent unpredicted economic and ecological consequences that will one day threaten life on Earth itself.
Simply put, if we don't protect nature, we can't protect ourselves.